Hello viewers. Now we will discuss problems on beta function as a continuation of what we discussed as problems on gamma function. Now beta function also has some properties similar to gamma function. First, let us see what is the definition of beta function and associated properties. Beta of m comma n is integral 0 to 1 x power m minus 1 minus x whole power n minus 1 into dx. There is an alternate form or another form of beta of m comma n, which is 2 times 0 to pi by 2 sine to the power of 2m minus 1 theta cos power 2n minus 1 theta d theta. And the most important property that will be useful for solving problem of beta function is beta of m comma n is equal to beta of n comma m. Now let us see some of the results that will be useful for solving problems in beta function. First one being integral 0 to 1 x power a 1 minus x whole power b dx is equal to beta of a plus 1 comma b plus 1, which means you are just adding 1 with the powers beta of a plus 1 comma b plus 1. 0 to pi by 2 sine power p theta cos power q theta d theta is equal to 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. Directly, these two results are derivable from the two forms we discussed in the previous slide. And the very important property that connects both beta and gamma function, which is the relation between beta and gamma function, given by beta of m comma n is equal to gamma of m into gamma of n by gamma of m plus n. This is what we are going to use in most of the problems as the last part of evaluation in beta function problems. Because there is no direct way to evaluate beta function. The only way to evaluate beta function or beta values is to use gamma values. Now let us see how to find solution of this problem using the above results. If we consider this problem 0 to 1 x power 6 1 minus x whole power 9 dx, we can directly compare this with integral 0 to 1 x power a 1 minus x whole power b dx is equal to beta of a plus 1 comma b plus 1. So from this, we find that value of a is equal to 6, value of b is equal to 9. So I can directly write this is equal to beta of 6 plus 1 comma 9 plus 1, which is equal to beta of 7 comma 10. Now how to evaluate beta of m comma n? Again we have a result. Beta of m comma n is equal to gamma of m, gamma of n whole divided by gamma of m plus n. So using this result, we can write this as gamma of 7 into gamma of 10 divided by gamma of 17. 7 plus 10 is 17. This is gamma of 7 is 6 factorial, gamma of 10 is 9 factorial, gamma of 17 is 16 factorial. You can very well simplify this using calculator. So the simplification part, I leave it to you, right? So this is a basic problem where you can directly apply the result of beta function to evaluate its value. Now let us proceed for another problem. 0 to pi by 2 sine power 6 theta cos power 10 theta d theta. Now what is the result we can apply here? Integral 0 to pi by 2 sine power p theta cos power q theta into d theta. This is 1 by 2 beta of p plus 1 by 2 comma q plus 1 by 2. This is derivable from the second form of beta function, which is 2 times 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. So comparing this, we get p is equal to 6, q is equal to 10. So this problem reduces to 1 by 2 times beta of 6 plus 1 by 2, comma 10 plus 1 by 2, which is equal to 1 by 2 beta of 7 by 2, comma 11 by 2. We already know how to evaluate these values. This is equal to 1 by 2. What is beta of m comma n? Gamma of m, gamma of n by gamma of m plus n. So gamma of 7 by 2 into gamma of 11 by 2 whole divided by gamma of 7 plus 11 divided by 2. So this is equal to 1 by 2 gamma of 7 by 2 gamma of 11 by 2 divided by gamma of 18 by 2, which is gamma of 9, which is equal to 1 by 2 times, what is gamma of 7 by 2? Starting with 1 less than 7 by 2 is 5 by 2. So it is 5 by 2, 3 by 2, 1 by 2 into gamma of 1 by 2. Either you can write gamma of 1 by 2 or you can directly substitute root pi, which is the value of gamma of 1 by 2. For 11 by 2, you start with 1 less, which is 9 by 2, 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2 into gamma of 1 by 2. Whole divided by gamma of 9 is 8 factorial. So that is equal to 1 by 2 times 1, 2, 3, 4, 5, 6, 7, 8. So 2 power 8. 2 power 8 into 2 is 2 power 9. And then numerators, you have 5 into 3 into 1 into 9 into 7 into 5 into 3 into 1. Gamma of half is root pi into root pi. So this value is root pi. And here one more root pi is there. Root pi into root pi is pi. Right? Into pi. Divided by 8 factorial is starting with 8. 7, 6, 5, 4, 3, 2, 1. Now certain terms will get cancelled. Which terms will get cancelled? 7 and 7 will get cancelled. And then 5, 3, 1 will get cancelled with this 5, 3, 1. And then 1, 6 will get cancelled 2 times. Here 3 times. That's all. So it is 8 into 2, 16. 16 into 4, 64. 64 into 2, 128. 128 is 2 to the power 7. 2 power 7, already 2 power 9 is there. So 2 power 16, you'll get 1 by 2 power 16 into, what else we have? 3 into 5, 15. 15 into 3 is 45. 45 pi. So we can better leave it as it is. 1 by 2 power 16, numerator 45 pi is the value of this integral. Again, the value of the integral is not so important, but the method to derive it is what is important, right? So next, let us proceed with this problem. 0 to pi by 2, root tan theta. Root tan theta, it is the way in which we bring it to beta function is the important step in this question than solving it, because you can write tan theta as sine by cos. So I can write this as 0 to pi by 2 root sine theta divided by root cos theta into d theta. In fact, square root is whole power half. Therefore, 0 to pi by 2, it is sine power half theta by cos power half theta d theta. Now bring everything to numerator. Integral 0 to pi by 2 sine power half theta cos power minus half theta d theta. This is equal to 1 by 2 times beta of p plus 1 by 2. Our p is 1 by 2. Our q is minus 1 by 2. So it is 1 by 2 plus 1 whole divided by 2 minus 1 by 2 plus 1 whole divided by 2. 1 by 2 plus 1 is 3 by 2. 3 by 2 by 2 is 3 by 4. So this is equal to 1 by 2 beta of 3 by 4, comma, minus 1 by 2 plus 1 is 1 by 2. 1 by 2 by 2 is 1 by 4, 1 by 4. So simplifying this further, this is equal to 1 by 2. The last step we had is beta of 3 by 4, comma 1 by 4. So it is gamma of 3 by 4 into gamma of 1 by 4 divided by gamma of 3 by 4 plus 1 by 4. Let me rewrite the numerator by writing 1 by 4 first, 3 by 4 next, which is equal to 1 by 2 gamma of 1 by 4 into gamma of 3 by 4 whole divided by 3 by 4 plus 1 by 4 is 1. So gamma of 1. Gamma of 1 is 1. This is equal to, now observe the result. Gamma of n into gamma of 1 minus n is sine pi by sine n pi. Pi by sine n pi. Here value of n is 1 by 4 because the value of n should lie in between 0 and 1. So if you substitute 1 by 4, you will get this is equal to 1 by 2 times gamma of 1 is 1. So it is pi divided by sine pi by 4, which is equal to 1 by 2 pi divided by 1 by root 2. These two will get cancelled. You will get pi by root 2 as the answer. So again, the answer is not so important. What is important is the method to solve it. Next problem is 0 to pi by 2 sine power 5 theta into d theta. Here also cos is missing. So we can write this as 0 to pi by 2 sine power 5 theta cos power 0 theta into d theta. Since we have done so many problems, we can directly write this as what? 1 by 2 beta of 5 plus 1 by 2, 3, comma 0 plus 1 by 2, 1 by 2, which in turn can be simplified to gamma of 3, gamma of 1 by 2 by gamma of 3 plus 1 by 2, which is 7 by 2. All of us know how to evaluate this. Gamma of 3 is 2 factorial, which is 2, into gamma of half is root pi, divided by gamma of 7 by 2 is 5 by 2, 3 by 2, 1 by 2 into root pi. So this 2 and 2 will get cancelled. Pi and pi will get cancelled. We will get 8 by 15 as the answer. Right? So we have discussed some problems involving beta functions as well. In the previous class, we discussed problems involving gamma functions as well. So hope the ideas which I shared with you will give you enormous information on how to solve problems involving gamma function and beta function using those results which we discussed directly based on the definition of beta function and various forms of beta and gamma function, right? Hope the video is clear. Hope all of you like the video. So we will meet again in some other time with some other topic. I'll stop with this. Thank you.